Hello, everyone. Thank you for taking the time from your busy schedule to attend the National Gypsum Company webinar. Before we start the AIA accredited portion, I want to introduce you to the construction design team. We are a resource for architects and specifiers around the country. My name is Pat Grotlich, and I cover the 11 Western states. Frank Fuller is in the Southwest. Thad Goodman, who is also presenting today, is in the central part of the U.S. Alan Zedick in the Southeast, Scott Hughes in the Northeast, and we have two people who work out of Charlotte, North Carolina in our corporate headquarters. Trang Schwartz responds to all of our sustainability inquiries and does a whole lot more. And Amy Hockett is a registered architect and manages our department. Another resource is the 1-800 phone line. When you call this number, you are connected to people who are technical experts in fire-rated assemblies, sound, and construction. National Gypsum Company has a dual approach to the marketplace. I mentioned that the construction design team is a resource for architects and specifiers. We also work with field sales reps from around the country, and some have been selected to be certified presenters and are qualified to present AIA accredited continuing education courses and help us to expand our reach. At nationalgypsum.com, if you click on our design center, you can download the Purple Book 2 and the SoundBook 2.0. The Purple Book 2 contains details on steel stud fire-rated assemblies, and the SoundBook 2.0 consists of details for 273 STC assemblies. We also provide these books free of charge. If you are interested in receiving them, please put that information into the Q&A box. If you have a question during the presentation, please enter it into the Q&A section. We will either answer it during the presentation or follow up with an email. This presentation provides you with one AIA, Health, Safety, and Welfare continuing education credit. Everyone who attends this webinar for a minimum of 50 minutes will receive a certificate. If you are joining us by phone, we only see your phone number. So please make sure that you enter your name and email address into our Q&A section so that we know who you are. This presentation is copyrighted by National Gypsum Company. That means that we can't send you the PowerPoint, but if you would like a PDF copy, we can do that, and please also enter that into the Q&A box. So today we're going to start off by talking about trends and acoustical concepts. We'll move on to acoustical terminology. It's important that all of us be on the same page as far as what these terms mean. Design considerations, sound reducing solutions. There are several in the marketplace, and they all have advantages and they all have disadvantages. We'll talk about codes and third-party recommendations, acoustics and fire ratings, and last but not least, cost comparisons. When we're talking about higher STCs, we're talking about additional dollars. So we want to compare the cost of several of these different options. Way back during the Great Recession, which seems like a very long time ago, people began moving out of single-family homes and moved into multifamily residences. When people live closer together, sound transmission and noise begins to be an issue. We began receiving a lot of phone calls and questions about sound transmission, noise, and acoustics in general. And we still do receive a lot of questions about this topic. The IBC allows a minimum STC rating of 50 between units in multifamily construction. And the USGBC and AIA have established minimum guidelines for schools and healthcare facilities. And we'll talk more about that in the coming slides. In 2001, J.S. Bradley, when he was affiliated with the National Research Council of Canada, conducted a survey, and it was later published. He visited 3 cities in Canada. He held face-to-face interviews with 600 multifamily residences. They had 300 party walls between them. It was a blind study, so he told them he was inquiring about a building satisfaction survey. He didn't mention acoustics. He also monitored the sound transmission loss of their party walls for 24 hours. These were people who were both owners and renters and lived in row houses and apartments. Their reaction and what the feedback they had regarding noise is not particularly surprising, but what this study did do was provide evidence-based research for our intuitive feelings about the negative effects of noise on our health and well-being. Residents with lower STC rated walls were more likely to say they wanted to move, they were awakened by noise, they had trouble falling asleep due to noise, and they thought their neighbors were less considerate. And some of the highest complaints occurred between 45 and 50 STC. So the general survey conclusions, they found that an STC of 55 is a realistic goal, but an STC of 60 is more ideal and practically eliminates negative effects of noises from neighbors. So some of the trends towards higher STC wall partitions. In education, LEED requires an STC 50 for core learning spaces. We know that children learn better with fewer distractions, and adults do as well. In healthcare, we passed the HIPAA law in 1996, and it completely changed the way healthcare facilities are designed, and it also placed a greater emphasis on sound transmission. The hospitality industry is a very competitive industry, and one of the ways they differentiate themselves from one another is to provide a quiet environment. I think probably many of you, like our team, probably traveled a great deal before COVID-19. One of the things that I always looked for was a quiet room. If I could hear that television, that flat screen in the room next to me, or people talking, I wouldn't go back to that hotel. So the key acoustical terms and concepts we're going to talk about: structure-borne sound, airborne sound, Hertz, decibels, flanking sound, sound transmission or STC, and noise reduction coefficient or NRC. Structure-borne sound is not really what this presentation is about. Structure-borne sound is sound that travels from a source to a receiving space, primarily by solid materials, and it travels much faster than airborne sound. Our team visited the acoustic lab at NGC Testing Services and experienced structure-borne sound. We stood in a room. Above us was a concrete floor ceiling assembly, and on that floor was a tapping machine. When they turned on that tapping machine, you could hear that sound just like it was next to us. This is an example of IIC, or the Impact Insulation Class Test. It tests the ability of a floor ceiling assembly to absorb or deflect structure-borne sound. Today we are talking about airborne sound. Airborne sound is acoustical energy in one space that's transmitted in the form of pressure wave variations to a receiver through the air. And we're talking about the receiver today as being the human auditory system. The way we hear that sound is by frequency. Here we mean pitch, and intensity of the pressure, or how loud it is. So it's energy generated by a source, transmitted through a medium, and received by a receiver. So the most common measure of frequency is called a Hertz. When we're very young, healthy children, we can hear between 20 Hertz and 20,000 Hertz, but that goes away pretty early. We know that people who are 30 years old and older, the vast majority of us do not hear 16,000 Hertz and above. Humans are most sensitive to the range of 100 Hertz to 8,000 Hertz, and most typical speech patterns are between 125 Hertz and 4,000 Hertz. And this is the range that we test for STC. If that sound is below 125 Hertz or above 4,000 Hertz, STC isn't testing for that. Now, 125 Hertz is similar to the low sounding feedback on a monitor, and 4,000 Hertz is similar to that shrieking feedback from a microphone. The next slide we're going to show you is a very fun video from National Geographic, and it illustrates how quickly adults lose their ability to hear those higher frequencies. You may want to play along and test your own hearing.
We've gathered a group of volunteers ranging in ages from 8 to 71 and are putting them to the test in our first Battle of the Ages contest.
All right, you guys, I'm going to play a series of sounds, and if you can hear the sound, I want you all to raise your hands up. Your right hand, you're going to keep it there, all right?
For those of you watching at home, feel free to play along.
Ready? 8,000 Hertz. All right. All of you can hear that first frequency. Now I'm going to play another sound in another frequency. If you still hear it, keep your hands up. If you can't, bring your hand down. 10,000 Hertz. Okay, we seem to have lost our 60 and over crowd. You guys look great, though. Let's raise the frequency even more. 14,000 Hertz. Okay, we lost you, we lost you. You're very fit, I can tell. 16,000 Hertz. Okay, at 16,000 Hertz, we've lost all of our grown-ups. But we still have our youngest members of the crowd with their hands up. Luke, tell everybody how old you are.
8.
8 years old. Your fresh ears still can pick up these faint frequencies.
I've been cleaning them.
Nice work. Now we're taking it up to 18,000 Hertz. You guys ready? 18,000 Hertz, we've lost 23 and 19, but the under 18 crowd is intact. 18,000 Hertz, that's pretty impressive. Enjoy it while it lasts.
Okay, back to terms and concepts. The intensity of sound, or how loud it is called a decibel. Decibels is a logarithmic unit of measurement. I live in California, so I think of a logarithmic measurement as in earthquakes. The difference between a 6.0 earthquake and a 7.0 earthquake is significant. It's the same with decibels, and it's actually the same with STC. So some typical decibel levels of some common sounds. A quiet whisper is 40 decibels. Normal conversation, 60 decibels. Loud singing, 75 decibels. A food blender, 90 decibels. When you get to 100 decibels or more, if you experience that frequently, you will damage your hearing. So the human sensitivity to changes in sound, and here we're talking about decibels. A change of 1 to 2 decibels is generally not perceptible. A change of 3 decibels is just perceptible. It's not until we get to 5 decibels that it's clearly noticeable. So a change of 10 decibels. So if we go from 30 decibels to 40 decibels, that sound is twice as loud. And if we go from a change of 20 decibels, go from 30 decibels to 50 decibels, that sound is 4 times as loud. So flanking sound. Flanking sound is the non-direct transmission of airborne sound, and the proper use of acoustical sealant or flexible caulking can reduce the effect of flanking sound. We're talking about places like the subfloor or joist cavity, And you want to make sure it's a flexible caulking, because as that building settles, you don't want to create gaps where there could be sound transmission. So in areas like the perimeter seal, the photo shows a worker applying fire-resistant acoustical sealant around the perimeter of a wall. Thad is going to talk about this more in coming slides. And at the top of a wall.
So Pat's done a good job of outlining sound transmission classification. Let's dig a little deeper into what it actually is. An STC number is actually a single number. It's a point on a graph in an arc that measures 16 different frequencies, as Pat said earlier, between 125 Hertz and 4,000 Hertz. So if we're working on if your client or your owner is working on a project that's got some sounds outside this range, STC really doesn't mean as much as it does when we're talking about normal speech patterns and the way things happen. Remember also that it's logarithmic, not linear. So again, the lower you are on the graph, a 32 or a 34, relatively easy to achieve. When we get up into the 50s, the upper 50s, into that 60 range, we're really creating a heavy lift. From a perspective of how we identify these products, how we measure these products, we want to make sure we're comparing apples to apples. So in your specifications and in your contract documents, please call out products from a sound perspective that are measured by ASTM E90, so that we know that all the products that you're comparing against each other have started from the same point. And then as far as how they're measured, ASTM E413 is the way we classify those within that graph. We talked a little bit about IIC. We talked a little bit about STC. We're going to spend a minute on NRC. That sound that's built up within a space. That's the noise pollution that happens within the walls that you're in. For example, we normally give this presentation in a conference room. Conference rooms are designed with typically carpet or softer materials on the floor, the side walls, maybe even a ceiling tile. You've got bodies in the seats, you've got cloth seats as a rule, something a little more comfortable for a longer period of time to sit for an hour or so to listen to a presentation like this. Sound in those areas is designed to bounce back and forth 2.5 to 3 times before it dies out. That's exactly right for auditory presentations. Now, let's say you were talking to somebody in that particular room and you moved over to go perhaps to a bathroom in the office. When you move into that space, those walls are typically hard surfaces and they're designed to repel water and protect against water. So at that point, your voice is starting to bounce back and forth 6 or 7 times before it dies out. It might even create enough of an echo that someone would say, "Where are you at all of a sudden? You sound different." This can happen inside a building. It can happen outside of a building. And so we've got a small video here to show the effects of what can happen outside a building when we have NRC challenges. And we're going to use one of the most famous speeches that I think has ever been made by a sports figure.
For the past 2 weeks, you've been reading about a bad rag. Today, I consider myself the luckiest man on the face of the earth. That I might have been given a bad break, but I've got an awful lot to live for. Thank you.
Gehrig was one of the most famous Yankees in a long line of famous Yankees to ever live. And if you're not familiar with what happened to him, he got ALS disease and had to retire at an earlier age. He did everything he did with grace, including deliver this final speech. So I'll give a shout out on the East Coast to all of our New York members. And I'd be remiss if I didn't at least talk, since I've got Pat on the line, and remind everybody that the Dodgers won the series. So as we talk about design considerations, we're going to move to the part in the presentation where we talk about how we protect spaces from one another. This is a HUD study, and the government always has the perfect answer. Their first bullet point is pretty simple. Let's just eliminate the cause of the noise. And in about 35 or 40 minutes, the noise on this presentation will be gone and you can get back to your lives. But that's not always the case. When I give presentations in downtown Chicago, for example, if I'm in an office where the L is moving across that room at some point, it's kind of hard to change that public transit system. We're not going to eliminate that noise. So how do we deal with that? Well, you can employ materials that absorb sound rather than reflect it. While that's not huge for STC, it does help reduce the volume of sound as it hits the wall, which can help slow things down. When we have design considerations that also use a topic called sound masking, and an example of that is, let's say you're in a hotel room like Pat talked about earlier, and you can hear the low thump of that, maybe that movie that somebody's watching on the other side of the wall. Many of the HVAC units have a constant fan mode, and you can go switch that on, and that constant hum of that fan can drown out the noise from the other side. That's called sound masking. And as adults, we typically can get accustomed to that sound and maybe even fall asleep to it. And then sound barriers is probably the most common way that we think in the architectural community about how we control sound from one side to the other. And that's basically creating something that goes in the way to slow the sound down. Now, there are three things that control sound: mass, space, and damping. Mass, pretty simple. I do presentations, like I said, in Cincinnati, downtown Chicago, areas where maybe there are buildings that were built pre-1900 that used 2 and 3 courses of block, brick, and they'll actually slow things down. It's almost like a tomb when you get into some of those areas, because you've got mass, a tremendous amount of mass holding whatever sound bounces around that room from getting out to the other side. When we talk about a drywall partition, there are some unique factors we need to consider when we think about how that sound travels from one side to the other with the mass products that we're using in today's world. A 25 gauge metal stud, 24 inches on center, does a couple things. That 25 gauge stud is soft enough and resilient enough that when sound vibrations hit it, they'll move a little bit and they'll start to deaden that sound out as it moves from one side of that partition to the other. When we move to a stiffer stud, let's say a 20 gauge stud, 16 on center, now instead of in that 4-foot space, instead of 3 contact points, we have 4. And think of thermal bridging, there's just more opportunities for things to travel through it. And then because it's stiffer, the sound tends to telegraph more easily. So understand that a 16 on center wall that's 25 gauge will far outperform, or a 24 inch on center wall will far outperform a 16 on center stud wall. Cavity absorption. When we get into the building industry, the home building industry, oftentimes we'll have a builder challenge us when there's sound transmission coming through and say, I soundproof that bedroom wall because I put insulation in it. Insulation, depending on the type of assembly, typically in a space of 2x4 or 3 5/8 metal studs, will add 1 to 3 STC points. So then the question becomes from the architectural community as we make these presentations, well, how about if I use unfaced versus faced? 1 to 3 STC points. How about if I use a 1/2 pound foam? I'm filling up the cavity, 1 to 3 STC points. How about if I use a 2 pound foam? 1 to 3 STC points. So if you're getting the idea that probably the best way that we can see that being advantageous is if you're to the point of a precipice where you're trying to meet what the owner's looking for. Let's say you're in a multifamily situation and you need to hit a 50. You found an untested wall, or you found a tested wall with no insulation in it, and it's a 49. You can rest relatively assured that if you add insulation into it, you'll be able to get there for your owner's requirements. Partition depth. So we went through mass, some of the different ways mass helps. How about space? The farther apart you put those two framing members, those walls of those membranes, the easier it is. Sound rushes out to hit that first one, starts to work its way through, vibrates through the first layer of that membrane. If it has to go more space, we've diminished the velocity of it. If there's more space until we get to the other side of it, it's going to be more effective. And then dampening is a little different. We'll talk about it a little later in the presentation, but for now, think of it like this. You have an empty wine glass and you ping it and it rings, and you put your hand on it and it stops. That's what a damped panel does in essence, and we'll explain it in more detail later. As Pat talked about, and we showed some of the slides of some of the different flanking paths that we have, your system is only going to be as effective as its weakest link. In many cases, that can be a window or a door. But even in a solid wall, you still have the opportunity to lose up to 10 STC points if you don't have it acoustically cocked correctly. One of the most common areas that we find where there's a misdirection or a misconnect in between the person putting up the drywall and the person putting up the floor trim is who's actually responsible to put that bottom part of that trim on. Traditionally, this is not something that the drywall contractor or the Division 9 contractor will be asked to do. GA 216, Gypsum Association's document 216 is going to ask that we keep the drywall off the floor so we don't wick water or have moisture issues. By the same token, we've got a spot where once that drywall is accomplished, we're far from being done with that unit or that part of the building. There's going to be a lot of other trades that are walking around there. There's going to be floors that need to be swept on a regular basis or cleaned up. So to put a non-hardening acoustical sealant in there is not probably in your best interest. But before the trim goes up, that's one piece of the puzzle that we need to solve because sound will pour underneath that wall if we haven't done it. So this is an excellent best practice. A couple other best practices. One is you don't put your outlets in the same cavity in the wall. You want to have as much mass in there. If air does leak in, if you look at the top left-hand side of the screen, there's a little green check mark. If you have sound leak into that left-hand box, it goes over to the other side and it rolls around that cavity without having a chance to get back out except in where it came in. If you go to the bottom part of that graphic, you can see that sound could go in through one of those, and if there was a hole in both of those boxes, it could come in one way and be out the other and be like a small microphone to amplify sound as it goes through and diminish the effectiveness of your demising wall. One additional way to help control that is to wrap the box with a sound putty. The putty pads are relatively inexpensive. Here we have a marketing picture of one that's very well put together. It just looks really nice. If you look in the bottom right-hand side of this picture of this screen to the picture on the right, you'll see traditionally how it's done more often in the field. This is fine as well. This was probably put up by the MEP person, which traditionally is where we'd like to see it. All it needs to be done is it just needs to be squeezed against the back of that box so we can stop any kind of holes and any kind of sound from going from one side to the other. On this page, we've listed a couple different manufacturers of putty pads, and we've also listed some acoustical sealant manufacturers and some of their products. We're not endorsing any one of these in this presentation, but we will tell you that we've used these in our own testing labs, and they all seem to work very well. Another best practice is to make sure that we stagger the joints on our walls. We traditionally do this anyway for fire resistant properties and structural properties for the wall, but it can also help from sound. If there's a crack on one side or the other, sound has to work its way all the way through the cavity to get to the other side. There are several existing solutions for how we make this work. Probably one of, if not the most popular, and one that's been around for over 60 years now, is the unbalanced RC1 wall system. This uses a combination of two of the things that I talked about earlier that control sound, mass and space. On the front side of this picture, where you can see the drywall and the two pieces of RC1, what you've basically done is you've started to decouple the wall and you've added some more space in that cavity. When you get to the other side, we traditionally have 2 layers of drywall on the other side. So you've added 3 layers of drywall in that wall assembly instead of 2. So you have more mass and you've created some more space. Now I could spend another hour talking strictly about RC1 channels and how many of them are different and they react differently, and that's for another presentation. But I'd like to spend a minute talking about the front end of the job and the back end of the job. The front end of the job is what we do. This is where we specify the product, we bid the project, we get the right contractor on the job, we do our CA work, we have an opportunity to see how it goes up, we have a good contractor on the job, and everything goes right. The RC1 is put up with the right size screws so we don't short circuit it. We make sure that they're the right side up and not the wrong side down. We make sure that the RC doesn't touch other members of the wall on the other side. We get everything done correctly, and it's a perfect wall in construction, as good as we can get it. We can control that. The problem is at some point we have to give the keys to the owner. Now, oftentimes when I'm giving a presentation in a conference room, there'll be a flat screen TV on one wall, there'll be a bookshelf on another wall that they'll have some resource materials because that's also a meeting room. There'll be a big whiteboard on one side of the wall that's all nailed to the wall in a conference room, where traditionally if you were going to use RC1, you'd have those systems in there. So understand that owners, especially owners that are transient, they move from one space to the other and they have sound requirements in their walls and they're told this is a sound room. And the first thing they do is they go up and start nailing stuff to the walls. They can compromise this system. So this is a very nice system if it's done correctly and it's treated correctly. It's been around for a long time and it's well proven. Probably the best sound wall that you can ever get is the one on the top part of this screen, the top graph in this screen. You decouple the wall totally, so any vibrations from one side die out in the middle of the cavity before you get to the other side, and you've got some extra space in between those membranes. That's a fantastic system. The problem that we have is it also takes up the most real estate, and it's also one of the most expensive to build. So sometimes a project's budget just doesn't give you the opportunity to use this one. One way to compromise that system and still get some of the effects is to use a common header and a footer and stagger the studs. In that particular case, you still get increased STCs over a single wall assembly, and you've taken up a little less space and used a little less material. Now, we give this presentation all over the country, and for some of you, this is something you may have never seen. But I grew up in the construction industry, and in the 60s and 70s, when the legacy codes were all around the country and the IBC and the IRC had not been formed yet, different parts of the country used this in wood frame construction, especially multifamily, as a great way to improve sound in demising walls. Wood fiber boards on both sides of the wall. And what happened is, as we moved to the IRC and the IBC, where we had a standard 50 STC, this fell out of favor in some areas because it only gets to a 49. It's still used in several different parts of the area. I see it some in northern Michigan. I see it some in the Southwest, Southeast. There's places where we see it specified still, so we know it's out there and we still like to talk about it. We just want people to understand that we've gone from a 32 or a 34 in our wood frame construction on a load-bearing wall, which is a low STC. We've gained a tremendous amount of space when we get to 49, but we're not quite to where legally a lot of owners are responsible. So if they have this requirement, you just need to be sure what you're recommending that they do. Another great option is a sound clip, RSIC clip, as it's commonly known in the industry. Great opportunity to start to deaden out sound because you take a stud and you've got a pneumatic pad on that clip and you attach it right to the stud. So you've got sound deadening qualities there. You've also got a channel to give you some more space. You've got some sound dampening qualities there. In this particular wood framed wall that's shown, a 57 is a fantastic STC. We tend to see this in multifamily, some of the higher end multifamily units, and we also see them in music facilities because they control a wider range of sound. It's a great product. It's a nice system. It's a little more expensive than maybe some of the other options that we've talked about because those clips are between $5 and $6 a piece. So just understand that while it gives you excellent performance in a wide range of frequencies, you also might need to prepare your owner for that gulp moment when he gets the bids back. Just another option.
So another option for achieving higher STCs is your damp panel solution. And this is the acoustically enhanced gypsum board. It's a 5/8 inch Type X mold and moisture resistant paper faced board. The paper is also abuse resistant. The core is silicone infused for additional mold and moisture resistance, and it's also extra dense. Thad talked about density helping increase STC. What you see here is 2 layers of 5/16 inch extra dense core with a thin layer of viscoelastic polymer in the center. Constrained layer damping is when you take a viscoelastic material and it's sandwiched between 2 stiffer materials. It was developed in the 1930s. It's used by the aerospace and military, so it's a proven technology. How it works is the viscoelastic polymer absorbs and dissipates noise by converting the vibrational airborne energy of sound waves into negligible heat. Some of the advantages of using acoustically enhanced gypsum board. First of all, it is a single layer application. It's the same thickness as standard drywall, but you can achieve much higher STCs, so it is maximizing your floor space. The focus is on speed and simplicity. It installs just like standard board, and it finishes just like standard board. So you're not asking your drywall installers to do anything they're not familiar with. And then it can also be used in conjunction with other sound damping techniques when you want to achieve a higher STC rating. So the 2 details that you see at the bottom of this slide were taken, the test was done at NGC Testing Services. Both of the details or the assemblies are based on U465, which is a generic, very common 1-hour steel stud assembly. Next to it is V438. That's a proprietary umbrella design, 1 to 4 hours. So we took a layer of 5/8 inch Type X board on each side of the assembly. You have 3 5/8 25 gauge steel studs 16 inches on center. Remember Thad talked about less framing is better. This is 16 inches on center with 3.5 inches of glass fiber insulation. In the lab, this tested to an STC of 43. The bottom detail is exactly the same as the top. All we did was replace a layer of 5/8 inch Type X with a layer of acoustically enhanced gypsum board. And in the lab, this assembly tested to an STC of 49. Remember, this is a logarithmic measurement, so this is an excellent result. So we're going to talk about codes and third-party recommendations. The International Green Construction Code Guide recommends two grades of acoustical performance beyond the current code minimum. So in the lab, a preferred performance grade A occupancy, STC of 60, an acceptable performance grade B occupancy, an STC of 55. Now we drop 5 points when we get to the field, and that preferred performance is a 55 STC, and an acceptable performance for grade B, a 50. The American National Standards Institute, the chart below lists the STC ratings required between rooms that separate a core learning space from an adjacent space. So a learning space, therapy room, or healthcare room next to a core learning space, an STC of 50. Next to a bathroom, a 53. A core learning space next to a corridor, staircase, office or conference room, an STC of 55. And a core learning space next to a music room, auditorium, mechanical equipment room, or cafeteria or gym, an STC of 60. The Academy of Architecture for Health references the guidelines for design and construction of hospitals for their minimum design requirements. So the adjacency combinations, a patient room to patient room between a wall on the same floor, an STC of 45. A patient room to patient room, floor to floor, is a 50. Patient room to corridor, an STC of 35, because we keep those patient doors open for line of sight safety. Exam room to public space, an STC of 50, and patient room to MRI room, a 60. And then finally, LEAD version 4 and LEAD version 4.1 offer one possible point, 2 for healthcare, for acoustical performance in the indoor environmental quality credit category. So adjacency combinations, if you go halfway down, standard office to standard office, an STC of 45, conference room to conference room, an STC of 50, and then mechanical equipment room to occupied area, an STC of 60.
So far in this presentation, we have thrown a lot of information at you. We'd like to wrap up with ways that you can have some cost comparisons with some of these different systems. So we took some of the most popular, and we started to compare them from a cost perspective. Our baseline is a standard non-bearing 1-hour wall. Understand that this is an RS means number that's finished completely to a level 4 with a 10-foot height. Now, for those on the phone that may not understand RS means, that's an average of 50 different major markets across the country. They take prices from installation from contractors and GCs all across the country, and they average them together. So when you look at this figure, this 539 a square foot for this 47 STC wall, please understand that if you're in San Francisco, this may seem a little low to you. If you're in New York on a union job, this may seem a little low to you. If you're in Waco, Texas, this may seem a little high. Or if you're somewhere up in the Rust Belt, it's kind of a mix. But this is our baseline, and this is what we will use to compare these different systems together. So this is where we start, and this is a typical 1-hour rated wall that gives us an opportunity to have some sound protection. We're going to start with our unbalanced RC1 wall. As I said earlier in the presentation, this one's been around for 60 years, and it's probably the one that we see almost as often as anything else. It's very, very popular. So as we look in, I'll let you start at the top slide, and we'll look at some of the differences. The first thing you'll notice is we've added space. So we've taken up a little real estate from your owner. If we get to the STC part of this slide, you can see that we've met the 50 requirement that we need to have in a laboratory. Now, Pat talked earlier about acceptable and desirable STCs in the laboratory and the field. Just like to make a quick comment here. Anything that you see in the laboratory, you probably will not ever achieve in the field. As a matter of fact, if you look in the code books, and any of you that have ever talked to a code official or ever fought with a code official, you know that they're pretty stringent with what they do and what they say. If you look in the IBC or the IRC, in those 2 paragraphs that outline code requirements, it says 50 lab, and in parentheses, it says 45 in the field. So there's an expectation that in the field, you can lose up to as much as 5 points and still be legally bound and be within the guidelines. One of the interesting things about an RC1 system or a double stud wall system is we typically see that 4 to 5 STC drop because we've got multiple pieces and parts that we move forward. But we've hit our 50 in the field, so we've kept ourselves legally safe. But please look down at the bottom and understand that we've added significant cost to this wall assembly. The reason that is because there's different pieces and parts, and every one of them goes up a little bit. And so we've got a little wider gap between the regular wall and the sound wall. This should tell your owner 2 things. And the main one is sound is expensive, because you're asking that wall to do 2 different things. You're asking that wall to provide fire protection, and you're asking that wall to provide sound protection. The other thing it'll tell the owner is that if I'm going to ask for sound protection, I better be pretty sure that I need it. So from a standpoint of comparison's sake, this is what it costs to get started down the road. Now, we talked about a damped panel being a thin wall application. So we've taken all those pieces and parts away in this slide, and we've taken one piece of 5/8 Type X out, and we've put one piece of damped panel in there. You'll see the significant reduction in cost. We went from $903 to $785 because we don't have as many pieces and parts. You'll notice that the acoustic board is more expensive, but there's less pieces and parts and labor to put it up. So the labor is where the major part of the savings comes. We struggle sometimes with this particular piece of the equation when we talk to contractors. They typically tend to price all these systems out exactly by the piece. And so when they get to the point where they start to talk about cost of an individual product, they go, wow, this is really much more expensive. But they tend to forget that sound is an assembly cost. And so we're creating an assembly to get where they need to be. Notice as we move up the graph, we've gone from a 50 to a 54. So you've had less cost and you've got 4 extra STC points that you've gained with the damped panel solution. You're getting bang for your buck in 2 different ways. And then the third piece of the puzzle I'd like to call your attention to is when you look at partition depth, the partition depth is the same because you're taking out a 5/8 product and you're putting in a 5/8 product. If you don't remember anything else that I said today, please understand that this sound solution is a great plug and play model when you're in the middle of a job. If you're a CA person or if you're in construction and you're an architect and they're making a change, the owner's changing the rules on you in the middle of the job. Let's say that the CEO wandered through the job once the drywall is up, which is where things tend to get more visible and more real for them because they can see the wall partitions and can't see through everything. And they say, well, I really don't want my office on this side of the building. I like the view over here better. So you might have had that wall already prepped to be a 47 or a 45, which is great for standard office building during a normal day. Or maybe it's even the HR department, and the HR department needs a little extra safety protection to make sure that nobody can hear what's going on in there. At that point, you've got some options. Let's say your door throats are already set and concreted in. Let's say your MEP is already done and your box is already set in conduit. For you to change that, make that one small change, when you start tearing all that stuff out to make it look right at the end, you can have significant time lost on the job and you can have significant cost. Your damped panel solution is going to cost you more money over what you had in that room originally, but it's going to give you an option, a great plug and play model to keep things moving quickly. A quick call to the dealer, get some other product out there, and you're moving down the road. One additional thing that we talked about was using what we traditionally think of as a 2-hour wall. Let's say we've got a situation where they say, well, let's just slap a couple extra pieces of drywall on both sides of that wall, and it's going to give you extra STC points. So again, let's start at the bottom. The damped panel is less money from a perspective of an average across the country. As we move up the road to the STC, the extra mass you're going to get with those 4 layers of drywall is going to give you a couple extra STC points, which may be very important depending on where your owner wants you to be, whether it's a 54, 55, 56. What's the number they're trying to hit at? And you've got a little more mass in that wall that's going to give you some protection as well. But then again, look at that top part of this graph. You're at 6 1/8 as opposed to 4 7/8. So you're still taking up real estate. So what is the most important thing for your owner? A great example of where this works out is if you look at what we traditionally call a luxury wall. When we get into that 60 STC, the difference between a 55 and 60 is a huge lift in a logarithmic scale like Pat was talking about. So if we go with a damped panel, this is a place where it may not work for you because it's going to cost you more money. You've got 1129 as opposed to 1078 for the same STC. In addition to that, let's remember what I said about a double partition wall where you've decoupled it in the middle. So your range of frequencies that are going to give you protection in that 60 is going to be wider than the one on the right-hand side where you've got single wall construction. all good reasons to be able to move to traditional 4 layers. Until you get to the top and you say, okay, what's the most important thing for your owner? Is it space or is it cost? Because it's going to take up an extra 3 inches of space. So again, we're not advocating one way or the other here. This is just to educate you on here's some of your options and here's what some of the costs are going to be. And hopefully today we've had a chance to do that for you. So as we start to wrap up, we think about the fact that over the past 10 years, gypsum manufacturers like ourselves have moved from getting about 95% of our calls for fire protection and ways we fire protect members, framing columns, members per people in the buildings, to the point where now we get about 45 to 50% of our calls have to do with sound and how to control sound pollution in the different types of products, buildings. LEED obviously works with healthcare, and with LEED 4 and 4.1, as Pat talked about, that acoustical credit that used to be specific to schools has extended to other parts of the building and the built envelope. Meeting the needs of your STCs, we've wrapped up several different ways for you to do that. We've introduced you hopefully to an acoustically enhanced gypsum board that's a true Type X, and it helps contain both that fire resistance and those acoustical qualities to give you another notch in your gun, another bullet in your chamber. This concludes the AIA portion of this program. We're running a little longer than we hoped to, so we're going to go ahead and just go into some information about our product and on who we are. We're going to have a Q&A sheet that will go out to all of the attendees who are here today, and we will make sure that we answer every question that came into the line. Again, we are National Gypsum. We're the largest domestically owned producer of drywall in the country. We have 4 different product lines. We have our Gold Bond building products, which is all of our standard drywall products. We have a cement board that's well known in the industry. We have our interior finishing products, so we can cover all those products that we put on the wall for you. And we have our Decibels, which is our roof board line, our glass mat roof board line. The product that we introduced today from an acoustical standpoint is called SoundBreak XP. There are 3 manufacturers of these products in the market space. There's 2 other manufacturers that have them here. So you can make sure that on your public buildings, if you choose this as an option, we can give you the chance to get a good quality quote. We have an entire family of products here. Our wallboard products, vertical applications. We've gone over them extensively, a little bit about what they are. They are UL classified. They are Type X products. The purple paper that you see wrapped around them is abuse and impact resistant, so we meet the scuff resistance on the ASTM C1629, so they can be used easily in heavy traffic areas, dormitories, schools, those sort of things. They are mold and mildew resistant. They can meet a perfect 10 on the ASTM 3273. We have a ceiling board that's excellent for floor ceiling assemblies, gives you some extra protection there from IIC and STC. And then we have a retrofit board where if you have an existing job with a tenant that moves in that's unhappy with the way sound works, or maybe somebody that's decided they want to have some extra protection. We've had a couple casinos, they've come to us and said, hey, we thought we did everything right, but we've got 200 rooms where we need to have some help. We can give you a product that can add extra STC right on top of the walls you have without demolition costs. These products are Green Guard Gold certified, so we can help with your sustainability needs. As I talked earlier, our XP boards are perfect for incidental moisture, and so we've got a complete line of them. When we get into more extreme situations, we have our EXP, our interior extreme, that's used in pre-rock applications. We have our tile backer products that can be used in lieu of a cement board in many applications. We have our shaft wall liner for unconditioned spaces in the lifetime of a building. And of course, our exterior sheathing and glass mat sheathing has been popular since the 80s. Again, just to dwell quickly on our PermaBase, a couple things that give it an advantage over some of the other ASTM 1325 products out there is we have a patented EdgeTech reinforced edge for easy nailing in between stud spaces. And then we have a cementitious core that is intertwined with some styrofoam beads that make it the lightest weight cement board in the industry. Our ProFirm products, we have a complete line. Well, we start in the bottom left with our hot muds, our speed set products that we use for heavier fills and some of those unconditioned spaces where you still need to have a quick set. We have a complete line of boxes and buckets to help contractors fit their needs, whatever their preference is. We have our FS90, which can be used in fire stop applications. And then we have a Dust Tech product that can help with your ocean needs because we can reduce the fallout from sanding drywall up to 60%. Pat touched earlier on our products that you can download. I'll start with the one on the right that we didn't talk about. That's our NGC construction guide. We used to have a binder, and now we have a booklet. And any three of these products can be completely downloaded from our website landing page. The NGC construction guide starts with a fire and sound selector, which will give you 1 to 4 hour, the most commonly used 1 to 4 hour rated assemblies you might use on your projects. And then we have application techniques and the correct way to install things. And when we get to the back, and in the middle of it, we have outlines and all the pretty pictures and marketing of all the products that we make and some middle sheet information. The Purple Book 2 was put together by a young architect that we have on staff. And when he came to us, he said, there's all kinds of testing for all the different wall assemblies, but there's really not very many resources out there for how these assemblies go together. So he took on that project and has done a wonderful job. This particular book is marketed to code officials and for checking different jobs and contractors across the country to be downloaded on their iPads. We have fire rated ceiling and wall assemblies, corner details. We have priority legends. If you're specifying a 2 hour that joins with a 1 hour wall or a 2 hour wall that goes in between a 1 hour wall, how should that be detailed and what should that look like? If you've got static or dynamic head of wall details, how should that be detailed and what should it look like? We've spent a lot of time talking about sound in this presentation. Our new SoundBook 2 has another 45 different wall assemblies. So if you have the SoundBook and it doesn't have the 2.0 on it, please let us know. We will get you an updated copy. Download one from the website, our landing page of the website or our design center. And we've added some new ceiling assemblies as well as some retrofit assemblies. The way it's laid out in the book is 16 on center assemblies, 24 on center assemblies, wood frame construction, and then chase walls and shaft walls. These particular pages there'll be 4 assemblies on each page, and you'll be able to quickly flip through. And because we're in a visual world, we're all visual by nature, we would have an opportunity to see what you think you're building. So you look at this particular graphic and you go, okay, here's what I think it is. Down below, we actually have the framing and the insulation and everything laid out so that you can see what you think you're looking at is actually what you're seeing. There'll be a UL number and reference on it if that's the case. If they have one, there'll be an STC number so you can quickly identify it. And as we've talked about in this presentation, oftentimes you'll be working with an acoustical consultant who will say, how does this product perform at a certain frequency that your owner isn't interested in? Well, we can give you a test number and you'll see different test numbers there. There's NGC testing services out of Buffalo, New York. You've got Orfield Labs out of Minneapolis, Minnesota, and in the Chicago area, we've got Riverbank Acoustical Labs. Those are the 3 independent testing labs that we use.
NationalGypsum.com is where you're going to find your resources. You want to click on the Design Center and you'll find our specifications there, information about our continuing education courses, all of our sustainability information, and the books, the technical books we have just been talking about. National Gypsum Company is committed to transparency and sustainability. All of our products are certified either Green Guard Gold or Green Guard. We have HPDs, which are Health Product Declarations, EPDs, Environmental Product Declarations, Declare labels. We are also listed in Sustainable Minds and Mindful Materials, the databases for sustainable for looking up sustainability. Our specifications you'll find on our design center. We have 3-part specs and drop-in specs. We also have links to BSD spec link and to product master spec. I mentioned this team before. This is the 1-800 team, the Construction Services Department. And they are available to answer technical questions about sound-rated assemblies, sound, and construction. 5 days a week, Monday through Friday, 8 a.m. to 4:45 p.m. East Coast time. Mark Chapman, I'll start left and go right. The man standing in the back is Mark Chapman. He's been in that department for 38 years. He came from the research center, and as a research engineer, he works closely with NGC testing services. Jim Farrell in the middle is a former contractor and understands the complexities of field-related issues. And then Sam Halverson, seated in the front, is an architect, and he was very instrumental in developing our SoundBooks, our Purple Book, and our NGC construction guide. We want to thank you for attending this webinar. We wish you all the very best for the holidays, and stay safe.